Let's go over the day 1 and day 2 assignments. Number 3 asks us, is this person accurate when they describe a confidence interval as 95% of all young men have scores between these two numbers? And of course, the student is wrong here. The student is confusing estimating a mean with probability of selecting someone out of a population. So 95% of all young men, that is talking about a population. A confidence interval is something different. We're just talking about the average score. These young men probably had much wider scores. Let's take a look at the answer that I wrote down. We're talking, this is what you should say. The student should have said a 95% probability that the interval, I didn't write the interval down, has captured the true mean. That is the average score. The population of scores may vary much more widely than this interval. Number 10.6, we have surveying hotel managers. And if you read through the problem, you're going to want to pull out the important numbers. There's a simple random sample of 160 hotels, and the simple random sample part will be important for what they call step 2 in the inference toolbox, but that is to figure out, can we even use a confidence interval procedure? And if you have an SRS and you have a big enough sample size, and sorry, that's not the sample size, that's the sample size, right? So that's interesting that they selected 160, but we're really interested in the responses. So here's the numbers that I pulled out. We've got N, 114, there's your sample mean, and there's your standard deviation. They ask for a 99% confidence level interval estimate, or just a confidence interval. So before we go leaping for the calculation, they ask us to go through these steps. Number 1, what are we doing? What are you trying to estimate? Well, if it's a mean or if it's a proportion, then we're good. Those are unbiased estimators, and we know that's going to equal the population parameter. Second, is it going to give us a normal distribution? Well, if it's a simple random sample, so sampling is proper, and it's a good enough, either you know the shape of the population or you've got a big enough sample size, then we can go ahead and use a normal curve. So those are just check and check, and you know if these don't check, then we can't do the problem. So it's probably safe to assume that those checked out. And now our 99% confidence interval is going to equal our x bar, and in this case we're using the z-table, so we're going to use that special critical value z-score times our estimate of the sampling standard deviation, which is this number given to us divided by square root of n. So now I've brought down, just plugging in the numbers, x bar is 11.78. What is this critical value? If you haven't seen where this comes from, let me show it to you. We won't do this every time, and these numbers should become real familiar soon. But if you look down, this is table C in the back of the book. And the confidence level for these z-scores, most of these are not z-scores on this table, they're actually t-scores, but the very bottom row here, we have the 99% confidence level, and that's our magic number right there, 2.576. So let's fill that in. The only color in this video. You do that multiplication and division, you get the original sample mean plus or minus 0.77. Okay, and then when you do that math, you get an interval of 1101 on the low end, and the high end of the interval is 1255. Okay, and then step 4 is to put this into English. Don't make the mistake from number 3 and say that 99% of these hotel managers work between 11 and 12 and a half years. No, this is just an estimate of the mean. So we say it's a 99% chance. Not that the true mean falls in here. Well, that's a classic mistake we need to avoid, that you'll get dinged on that. We want to say it's a chance that this interval has accurately captured the true mean.